Hello friends, welcome to my session. In this session, I'm going to introduce about the interpolation. Basically, what is the interpolation? Interpolation is a technique. Interpolation is a technique to calculate the random value of y, where y is depend on the x value, and we can calculate the value of y with the help of x. So I can see that the interpolation is what? Interpolation is a technique to getting the missing value of y from the table. See, let y is equals to f of x be my function, where y is depend on x, x is independent variable. If I put some situation, then I get the different value of x, corresponding I get the different value of y. So basically these are the relation between x and y. If I want to tabulate the value of x and y, then my table column contain the x and y variable, right? My first value of y, x is x naught, then corresponding value of y is y naught. Reason behind, we have a relation between y and x. If I initialize this x value with x naught, somehow I get the y naught value. If I initialize this x with x1, somehow I get the y1 value. So my second value is for the x1, corresponding value of y is y1. I can get this x1 value with x naught plus h if I know about the difference, if I know about the h value. H is what? H is a difference between two x value, which is calculated by x2 minus x1. For the next value, this is x2, I can calculate this x2 value with the x1 plus h, a single increment in x1 position, or I can calculate this value by the 2 times increment in x0 position. This is how we construct a column values xn, x0 plus nh, which is my nth value of x. Corresponding value of y is y2, which is y1 plus h, and corresponding value of y for xn position is yn. If, for example, if I have a finite data like 10, 20, 30 and 40, these are the value of x. Corresponding value of y is given, which is f of x. If I have the random values, this is my y value. I have two column in my table, x and y, and my question is, we have to find the value of y at x equals to 11. In this question, I have a position value. If my x value is 10, I get the y value is 12. Why? If I get the x is equals to 20, I have a value of 11. But for x equals to 11, that means x equals to 11 is lie between these two variable. If I initialize the position value, I get x naught equals to 10, and this is my x1. Correct? That means given value of x, where we have to find the value of y, is lie between this interval. For this type of the problem, always this problem can be solved by the interpolation technique. So basically, interpolation technique give a convenient method to solve the missing value of y where x is given. But the condition for this interpolation is your given value of x, where you have to find the value of y, is lie between the range. That means if I have a value of x equals to 11 and my given range will be started with 10 to 40, then I have to check that the given value of x is lie between the range. If my given value of x is lie between the range, then this technique is known as a interpolation. But if it is not, then this technique is known as a extrapolation. Right? So basically, in interpolation, we divide our interpolation into two categories. The first category is interpolation with equal interval, and another category is interpolation with unequal interval. How? See, we assumed that our function is equals to y equals to f of x, right? That means the calculation of y is directly depend on the value of x. And x is what? It's a data type, it's a variable value, right? From this tabulation part, we can easily calculate the value of x and easily calculate the value of y, correct? If we know about the function definition. But my suggestion is that if we have a value of x, then we have to check that our given value of x is equally distributed or not. If my given value of x is equally distributed, that means every time for every interval I get the same value of h. I get the same value of x by x1 minus x0 calculation. I get the same value of h by x2 minus x1 calculation, and so on. If I get the same value of h for entire x table, then I can say that this x value is equally distributed. Otherwise, it is not. If my data is equally distributed, then I apply interpolation with equal interval category. In this category, I have two methods of the interpolation. The first method is Newton forward interpolation and another is Newton backward interpolation. For Newton forward interpolation, for the forward, I write the delta symbol. For Newton backward interpolation, I write the nabla symbol. If my data is not equally distributed, which is I told you, if my data is not equally distributed, then again we have two techniques of the interpolation. First one is your Lagrange interpolation, another one is Newton divide and difference interpolation, and which is given by divide and difference operator. In previous session, we discussed about operators in which I is our identity operator, E shift operator, E inverse shift operator, delta forward difference operator, nabla backward difference operator, right? With the help of this operator definition, now I will introduce you to the interpolation technique. Newton forward interpolation, which is based on the forward difference operator, right? So, before we start the Newton forward interpolation technique, I just wanted to explain that if your data is equally spread or if your data is equally distributed, then you apply these two techniques. But if your data is not equally distributed, then you have two options, Lagrange and Newton divide and difference. Correct? From all four methods, Newton divide and difference is the most efficient method. Why? Because Newton divide and difference, where we use the divide and difference operator, get the highest rate of convergence. Highest rate of convergence, that means getting a approximate answer nearby a accurate answer. As I told you, interpolation or entire numerical method technique not give us a exact answer. Numerical method always give us a approximate answer, right? So from all four, Newton divide and difference give the most approximate answer, which is lie of lump sum, which is your accurate answer. Correct? So you can apply Newton divide and difference for both type of the case. Later on we will discuss on Newton divide and difference. Now we will start with your first method, Newton forward interpolation. Before we start your Newton forward interpolation, I am going to show you how to construct the table for forward difference operator. For forward difference operator, if we have this value, this x and y value, that means the next column contains delta of y. And delta of f of x is given by f of x plus h minus f of x. That means if I initialize this x value with x naught position, I get delta of f of x naught minus f of x1 minus f of x naught. That means I get delta of y1 equals to delta of y naught equals to y1 minus y naught. So for delta of initial value, for the delta of y naught, we are doing the calculation of y1 minus y2. So the first value, the first difference between y1 minus y naught gives the value of delta of y naught. Then y2 minus y1 give the value of delta of, delta of y naught is a difference between these two. So position of delta of y naught is always between these two data. You can't set delta of y naught at the same position at y naught or same position at y1. Every time you have to place this delta of y naught between the y naught and y1. Reason behind the delta of y naught is a difference. Then y2 minus y1 equals to delta of y1. Similarly, y3 minus y1 is delta of y2. If I am taking the finite value of x and y, then my table is look like, here I have x3, here corresponding value of y3, here I have x4, corresponding value of y4, right? y3 minus y2 is always give the delta of y2. y4 minus y3 is always give the delta of y3. So these are the column value of delta of y.